Hey,
Hey.
it's Mr. Barre. It's the 9th of October. It's the 10th. It's the 10th of October, 2019. Math 1, real life models. Here we go. What is the learning goal? Let's start with the Chris. The Chris. Linear. Excellent. And what's our Y? Let's go with greenly on the Y.
Line equations will help me understand the world around me and make predictions.
Excellent. We have two types of equations that we've been working with. What are they? Raising a hand. Boom.
Intercept and slope.
Slope-intercept equation, that's one of them. The other one? Okay, I got ahead of myself. Let me do this one. Well, actually, it's right here. So far, we've been using the slope-intercept equation and the standard equation. Those are our two equations to model different types of things. Today, I'm just going to throw both of them at you at the same time and see if you know which one to use when. This is taking the last two lessons and putting them together into one lesson. Here are our two equations. We have slope-intercept. So in our notes, we're going to use slope-intercept. Slope. Intercept. Y equals mx plus b. M is the slope, or how it's changing. What do I have there? Changing value. And b is the start. This is good for things like I have $10 and I get $2 a day. Or it could be I have 100 Skittles and every minute I eat one. Yes? Do you like Skittles? Skittles are good. Oh, I watched the thing on freeze-drying Skittles.
Oh, I heard that.
I've heard they're really good too. A bag of them cost like $20 though. No, it wasn't $20. It was $5.50 for 4 ounces. That doesn't seem too outrageous. I kind of want to buy them. Or I could just buy my own freeze-dry machine and make my own.
I mean, it's also
Freeze-dry machine costs $2,000.
yeah.
Standard form. Standard form is AX plus BY equals C. And this is really good when you have like two different kind of things like apples and bananas and a total. So C is the total. And A and B are actually the intercepts. They lead to the intercepts. They're not the intercepts. But they help me find the intercepts. Hey, Gavin.
Hi. So I was wondering, what it like the equal to C thing? Could you put that on the other end?
You
too,
could.
like
You could take the entire thing and make it C equals AX plus BY.
Could you do the same thing with the slope one?
You could. You could go MX plus B equals Y, MX plus B equals Y. It just doesn't sound as cool as Y equals MX plus B. Here we go. The rest of this lesson you're going to do on whiteboards, but I will be giving you some graph paper in a moment. So let's start with whiteboards and teach you to model this.
Yesterday too. We wrote down some rules. What's it called? Stepped on them, and so they came and tied.
Yes. Yeah, go to the bathroom though.
Stop.
All right, model this for me. Bananas cost $2.50 a pound. Use B for bananas. Apples cost $2 a pound. Use A for apples. You have $25 to spend. Model this with an equation. Good. Do not erase it.
Oh.
Good. Do not erase it. Good. Do not erase it. Don't erase it. Use A's and B's instead of X's and Y's. Good. Good. Don't erase it. Don't erase it. It's not an inequality today. Just make it an equation. Good. It's beautiful. That's good. Good. So I have it as now I'm going to start talking to people. I will start with Chris. Chris, what does the 2.5 represent? Bananas per pound. I'm gonna come back. It's the cost. It's the price of bananas per pound, correct? Okay. Lizette, what does the B stand for? How many bananas? Jackson. So what does 2.5 B?
The total number of bananas.
It's not.
Or the cost of the total number.
It's the cost of the bananas, the total cost of the bananas I buy. All right. Jordan, what's the 2 represent?
The 2 represents the amount of apples, right? Yes, apples. Like how much of 1 apple. So like
The price for a pound, is it pounds of apples?
I
Yes.
think, yeah.
The price per pound for apples?
Yes.
Presley, what's the A step? Step
How
for?
many apples you buy?
How many apples I buy? Taryn, what's 2A? It's the total price of all the apples I buy. And then what's the 25 there, Gavin?
It's how much you can spend.
It's how much I can spend. We're now going to graph this thing. I'm going to give you a piece of graph paper, but not yet. So I need you to listen to me first. Mr. Johnny face. Yep, let's do Johnny face. Today's graphs, it's only a half fold, and you're making this kind of a coordinate system. Do I want this one? No. This one? Yes. Say yes. Yes.
Wait.
No.
No, I mean like this way.
Model, this is what I need on your graph paper.
Either way.
This is what I need on your graph paper. This. You're drawing this on the graph paper. Are you drawing this?
No.
This. There we go. I'm going to give you graph paper. Look, it's pre-folded. Thank you. It's because you're my favorite. Is that? How many rulers do they need them? You make all these rulers and get them if you need them.
Wow. That's mean.
Okay.
Yeah, I'm sure you're not sure all this is from what you really love it, so I don't know.
See if you can graph this thing. Graph this banana and apple extravaganza.
Oh, wait, no.
No, that doesn't. You graph it. Apple banana extravaganza. Banana, banana, banana.
Thank you.
What's banana? Banana? 10 bananas? And 12 and a half apples? Is that right?
Two apples and
No, wait.
$2 for apples.
No, that's not 10 bananas. And 12 and a half. Do you have a graph? Are you guys waiting for me to graph it for you?
No, I was confused on
This has it? That's not. That looks good. Right? Mini me? Oh. 2.5b equals 25. 2a equals 25. B equals 10. A equals 12.5.
Wait, how do you? Oh, would it be divided?
Yeah, so dividing both sides by 2.5, dividing both sides by 2.
Oh.
Graphing out of standard form. You got a graph? Does it look like Mike's? Well, is it going to look like mine? But now you got to connect the dots. But let's assume you can't buy a half a pound. This line is saying you can buy like a tenth of a pound, a third of a pound, a half. But no, I want some viable solutions. What are the real solutions here? This line is saying, oh, I can buy fractional bananas. What is, first of all, let's start with the word viable. What does viable mean? Look it up. Viable. JJ?
Capable of working
Successfully. Capable of working successfully. Can I go into the store and buy 9.83 pounds? No. Let's say that I have to buy whole pounds. 1 pound, 2 pounds, 3 pounds. So what's a viable answer to this? Yeah, Jackson.
You would put separate dots, not a straight line.
So, right, there'd be separate dots, but give me the separate dots. Give me a viable solution. If you look at your graph paper, you should be able to see at least two. I think there are 3 viable solutions for this. Presley?
So the bananas would be 2, and then the apples 10.
2 comma 10. That's a viable solution. It actually works, assuming we can't go fractional. There's another viable solution. Aiden.
Is it 6, 5?
6 comma 5 is a viable solution. That would be 6 bananas, which is $15 and 10, and then 5 apples, which would be $10, which takes me to 25. Good. Is this a viable solution? 12 and a half.
No.
So really, those are the only possible things you could even do. These are the viable solutions. The line is correct. I mean, that's the line of the graph. But the viable solutions are those 3 points. Viable. What was your definition for viable again?
It's working in a successful way.
It works successfully. In biology, viability means capable of life. So at some point, an embryo becomes viable, it becomes capable of life, yes.
So like on the test, can we just put the line, or would we have to have the 3 dots?
You really have to read the question. It is asking for viable answers. It is asking for you to graph it. Read it. If you look at the pre-test, you'll see what the question looks like. This one. On your whiteboard, I want the equation that matches. I disagree. I agree with you. So this isn't a slope intercept. A slope intercept would be I have a starting value and a changing value. There's no change going on here. This is like an apple banana problem. I disagree. Because those are not the those intercepts are not the prices. Here, I want you to go over here. If I spend all my money on adult tickets, how many adult tickets can I buy? I spend all my money on how many?
4.
Nope.
Wait, no?
If I spend all my money on adult tickets, I can buy 10. So how much is an adult ticket?
$4.
It's like the banana problem. If I spend all my money on kid tickets, how many can I get?
Wait,
Good.
no. 10. Wait, no, I'm in your 8.
I spend all my money on kid tickets, I get 8 of them. So how much is a kid ticket?
5.
$5.
Why'd you say kids tickets are more expensive? Oh, wait.
Because kid
Never
tickets
mind.
are more expensive.
I got you.
Wait,
That
Right,
makes no
so-
sense. Why would
because
they-
the price-
No, like why would the kid take it?
Ignore it. It's just the way I created the graph. So, Fisher, let's say I buy no adult tickets. This is telling me I would get 8 kid tickets. 8 kid tickets for $40.
oh,
$5 for a kid ticket. Ignore the kids. Let's get all adult tickets. Come over here. 10 adult tickets for $40. Now build the equation. Good. Everyone show me the new boards. Nope. So you're still working. It's apples and bananas. What's the cost of a kid ticket? What's the cost of an adult ticket? Right? My kid ticket is 8. Where'd you get the 8 from? You do it. 5 divided by 4 is an 8. Good, 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 good. Check it again. Finish it again. I think you're on the wrong one. How much? Are you happier with that?
yeah.
So I get it. This is not the price of a kid ticket. This is not the price of an adult ticket. It's the number. I have to back out the prices. So, Taryn, I'm going to spend $40. I spent $40 and I got 10 adult tickets. So how much is one adult ticket? $4. I had $40 to spend and I got 8 kid tickets. So kid tickets are $5. So it's just like bananas and apples again, right? $5 for bananas, $4 for apples. $5 for kids, $4 for adults. And I know it doesn't make sense because usually kids are cheaper. Number this one. So I'll tell you what I see this, what you're saying. You're spending hold on to that, don't do anything with it. Don't go anywhere. Please. Good, don't erase it. Hold on to it. Not X and Y. Good, hold on to that for a minute. That's right. It's better for you. Not X and Y's. Not X and Y. No, you're good. W, not Y. I don't want a Y there. So let me take that. Good. Good. Better. Hold on to that. Good. So my equation. Now use this equation and tell me how much money I would have after 12 weeks. Write down the whiteboard.
It's 400.
It's, oh, maybe in your world, I make 4,000 a week. Okay, yeah, it's 400.
I wish it was more.
Thanks, JJ. Ruining my hopes, my dreams, my ambitions. It's a big difference, 4,000 a week versus 400 a week. That's like an extra 0 a week. Right? This is 400 to 4,000. That's just a 0. I don't need an extra 0. That means yes. That means yes.
Oh.
Coming back here. That means yes. Nico, you've got it. 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 Yep, you don't have it. What about the 3,000? Any question? What about you, Maddie? When you were watching yesterday, did you have like food next to you? Yeah, what were you eating?
I was eating chips and salsa.
That's what I thought you were eating. Oh, that seems like way too much money. 12 weeks? 400
Oh,
times
wait,
12?
oops, I was doing.
Are you using a, yeah, like me. That looks good. 4,000, who's got a calculator out? Can I borrow yours?
Yeah.
4,000 a week. Dude, that's a chunk of money. That's $208,000 a year. Next one. Hold on to that.
Wait, can I just write hours for 20 years an hour?
You gotta create the equation that models this. Yes. Maddie Heller. Yes. Yes. Got it. Yes. How about you, Miranda? No. That means that if he works for 2 hours, he gets $140. So that works. There's a 0 there. I'm not sure why there's a 0. And then M. Oh, M and D. Oh, no.
Wait.
I'm an H.
That'll work. Is this a slope intercept or a standard? It's a slope intercept. It's got a starting value. Like, how much does this guy start?
He starts off.
What, he starts at with $70.
Oh, alright. Wait, can I get a good? Wait. Wait, that's 30.
Oh,
Isn't it? It was 100. If you line up on 1 with 100, like
It
points
starts-
like this, and it's like
how much at 0 hours? How much money does he have?
7,
At 1 hour, how much does he have?
107.
So right here, he starts off at 70. That's his y-intercept. His slope, ready? At 1 hour, he's got $100. So how much did he make in that 1 hour?
That 1 hour.
No. No. He made $30. Just for showing up. He shows up, boom, he's got $70 in his pocket. An hour later, how much does he have? He gets an extra 30, now he's at $100. An hour later, what's he at? 130. An hour later, he's at 160. So this is my equation. What does the 30 represent, Gavin?
The amount of money he gets per hour.
The amount of money he gets per hour. Presley, what does the H represent?
How many hours?
How many hours he works. Nico, so what does the 30H represent?
How much money he gets from like the hourly.
How much money he gets, yeah, from his hourly, from working. This is how much he made for working. what is, Greenlee, what does the 70 represent?
The 70 represents what he starts off by getting paid. When
Yeah.
he gets there, how much?
Right, that's just his fee for just showing up. He makes $70 just for showing up, then he makes $30 an hour. And then that's his total right there. Questions? Questions? I know, man, we're lacking energy right now. I got you. All right, I think we got one more problem here. Oh my goodness, let's skip the carnival one and go to the donut one. And let's use D for donuts and C for coffees. D for donuts, C for coffee. D for donuts, C for coffee.
Oh.
Because you're just looking at those numbers. If I spent all my money on coffee, it's going to be $3 a cup.
Oh, yeah.
Because $27, I got 9, so it's $3 a cup for coffee.
That's what it is.
Donuts, I'm spending all my money, 27 divided by 6 gives me my coffee.
I didn't
donut.
divide it.
I know what you didn't do. Place all right. Oh, you did.
Wait.
Donuts and coffee. I feel like we should take a field trip to a donut place.
Yes, I agree.
We're not going to. You know why? Because they tore down the donut place.
Wait, which one?
There used to be one where the music center is. Or the
Oh, I know that one.
Oh, yeah.
Right.
It's like a regular one.
And like a couple years ago, I'd be making field trips there every day. But now,
You have to drive all the way down the boulevard.
I gotta drive all the way down the boulevard. They might sell ones that sale drug, like ones in little packages.
Just show them that.
Yeah, but those aren't as good.
Yeah, those
Yeah, but they're
Remember,
close.
isn't the one like down the boulevard like?
Hey, who's ever been to sale drug? This is kind of cool, isn't it? It's kind of like stepping back into
It's got a lot of stuff in there, but it's all like cheap stuff. So it's
You
not
could,
like,
you can Chris would do it.
You went to the sale drug? What'd you get?
An apple pie.
Like a little, like the one of those rectangle ones? Sounds about right. So, if I spend all my money on coffee, how many coffees do I get?
You get 3. Well, 9.
Nine.
I get 9. So, what's the cost of a coffee? Coffee?
$3.
If I spend all my money on donuts, how many donuts do I get?
Donuts.
So, what's the cost of a donut?
$4.50.
Chris, so it's an apple banana problem. It's a donut coffee problem. It's a standard form problem. It's not a slope intercept.
You're tricking. It said slope intercept is standard. And so that also is like slope intercept.
What type of equation should you use? Standard. 3c plus 4.5d equals 27.
Would be slope would it have worked?
Well, what's your equation?
Y equals 2.
No, because this is d's and c's, not even y's and x's.
Well, then
No, I guess what you would have, we'll see. Y equals negative 2/3 x plus 6. Was that your equation?
yeah.
Yeah, but it doesn't model it. It doesn't. What does this say? What does this equation do for us? All right, let's just stop there. You guys start on the homework.